obviously, this is fixed, right? We can write a third one, but this is fixed. Now, what happens to here is Q changes. Why? Because its X changes. 4.1, 4.05, 4.01. Okay, so let's create a slope of the secant line, PQ, without putting in the Q. I don't want to put in the Q for now. Q is Q. No numbers in. So point P is 4, comma 275 minus 16 times 16 because it's 4 squared. But Q is X, comma 207, oh, T, sorry. T, comma 275 minus 16T squared. So in order to determine the slope of the secant line, I have y2 minus y1 over x2 minus x1. So I have 275 minus 16t squared, and minus this number, which I will get quickly. What is it? 275 minus 16 squared. What do I get? 19. Divided by t minus 4. Remember, this is what we did twice tonight. What do I mean by that? y2 minus y1 over x2 minus x1.
Okay, wait, I kind of got confused. So you basically all you did is like you multiply, well, you solved for like y equals 275 minus 16t.
So this function, assuming it's a quadratic function with a maximum, but let's say it's this function. We have p here, which has 4, comma 19. You understand that part, right?
Yeah.
Okay, and we have q here, which has coordinates t, comma y. T, comma y. And I'm just determining the slope of this line. Y minus 19 over t minus 4. Is that okay?
Somewhat.
So, yes, go ahead.
Where does the 19 come from? I know where the 275 minus 16t.
Okay. So remember the question here was, when this is 4, how do I determine this?
Okay.
So when this is 4, I have to plug in the function and I get 19. 275 minus 16 squared.
So you plugged in 4 to get the 19 into the function?
When x is 4, we determine f of 4.
Sorry, I think the confusion is we're doing the difference quotient for the point Q and the point.
We haven't gotten to that. The question is we haven't gotten to that. Hold on. The question was, how did we get 19? I haven't gotten to that yet. Do we hold your thought? Hold your thought. We're going to get to that question in a minute. Do we understand how we get the 19 now?
Yeah.
Okay, so now let's move on. What was the next question? Chris, go ahead. Ask your next question now. I wanted to make sure.
I believe the question was like, how did we get the 19? And then why, I believe that the next logical step would be like, why is the 19 there? In our formula 275 minus 16 t squared minus 19.
So the first question was clear. The answer was 19, and we understand that. So now you're asking this. Is that the second question?
Yes.
Okay.
Yes.
Okay. Hold on. F of x plus h minus 19 over 4 minus 19. over x plus h minus 4. It's the same formula that we used 3 times. So it's y2 minus y1 over x2 minus x1. I have 2 points. y2 minus 19 over x2 minus 4.
Yes. Thank you.
Is that clear? So I know it looks differently, but it's the same formula that we applied 3 times. So again, I have a point that is 4 comma 19, and I have a generic point t comma f of t. And now I'm creating the slope. y2 minus y1 over x2 minus x1. y2, I calculated this to be 19, unless I calculated wrong, over t minus 4. And that's the slope of the secant line. Now, you can repeat this process 3 times, but I want to just show you the easiest way. We created a generic slope in y equals. I enter it. Do not forget parentheses, this is crucial. 275 minus 16 t squared.
I get it.
Minus 19. If there is a question, let me know. And divide by t minus 4. And now remember, our x for q is 4.05, 4.1, or 4.01. So we are getting closer and closer to 4.
Did you mean to write 19? Because you wrote 1.
Of course, I meant to write 19. Thank you, thank you. Oh, I didn't mean to do that. I meant to do this. Of course, that's exactly what I meant to write. Thank you so much, thank you so much. Thank you. So then I want second and table, and I will plug in numbers closer and closer to 4. So first, 4.1, and enter. And that is the slope. And then 4.05, and then 4.01. And you can say this is still too far away from 4. Okay, 4.0000001. Oh, look at that. But what if I plug in 4? What happens if I plug in 4? Let's look here for a second. What happens if I plug in 4?
It'll get 0.
Careful. What happens to a fraction when the denominator is...
vertical asymptote. Oh yeah, there you go.
It will tell me what? So what is a number divided by 0 called?
Non-real number?
It's non-existent, but it has a special name that we like to use. Kind of fancy.
Vertical asymptote.
Correct, but it's still another name. Division by 0 is called?
I can't remember it. Undefined.
It is called undefined. So now if I plug in 4, because I want the slope at 4, the calculator will scream at me saying, lady, you lost your mind. But if I plug in 4.000000001, it gives me what I want to determine. So here's how we present the information. So t and the slope. So I'm going to leave the 4 blank for now. For 4.1, for 4.05, and for 4.01, I really wanted to put them reversed in the correct order, so I'm going to erase this from here because I don't want it there. Okay. See, that's why I have my whiteout here in case I need it. So 4.1, 4.05, 4.01, only because I should have presented them for 4.01 in the correct order from left to right, but since it's easier to erase 1 than 3, I put them like that. So back to our answer. So the slope of the secant line is negative, highlighted. So you can see at least, I don't know, the whole, see if there is anything following. So negative 129.6. The next one is negative 128.8. The next one is negative 128.2. And can anyone guess what is the slope of the tangent line at 4? Anyone can guess?
Negative 128.
Thank you very much. Negative 128, indeed. So that's how we solve the problem. I recommend create the slope of the secant line, or repeat the process 3 times, which I don't recommend. Very easy to make an error. I would never determine this. I would never determine y of 4.05. Why? There is no need. I will create y2 minus y1 over x2 minus x1. That's what I have here. I will not mess with the q at all, with a t in q. And just afterwards, put this in the graphing calculator and put the t I want, 4.1, 4.05, and then 4.01. And then, and then go as close as possible to 4 so you can determine the slope of the tangent line. In other words, the instantaneous rate of change at 4. Any questions on this? Any questions? Again, you don't have to do this. This is a shortcut. This is the best way, in my opinion, anyway. Otherwise, you will have to determine the function value at 4.1, subtract the function value at 4, subtract over 4.1 minus 4, and then repeat for the other two. Why? I can create this, y2 minus y1 over x2 minus x1, and then plug in the numbers in the graphing calculator. Okay, so now continuing with limits. So this is 2.2, limits. Okay. So this is a very important topic in calculus. You will never get away from it, no matter what calculus level you continue until. Limits will always be there. So what is this? What is the limit? What does it mean? So I wanted to understand that the limit is an operator. What does an operator do? Operator on a function. What is this operator? What does it mean? Okay, so let's say I have the square root of f of x. This is an operator. This is the square root operator. It does something to a function. What does it do? It takes the square root. This is another operator. What is it? It's the log operator. It determines a power. The power we raise 4 to get f of x. It does something to a function. And I can continue forever. Well, let's say f of x to the 3rd power. This is an operator. This is an operator. Power 3 is an operator. What does it do? It takes this function to the 3rd power. The limit is an operator. What does it do? So when we look at the limit, LIM, of a function when x approaches a number. So I'm going to write this how we read it first. Limit of f of x as x approaches a, this little number, from either side you can say, all this is in here? Yes, all this is in here. The limit of f of x as x approaches a from either side. There are two other options, from the left and from the right, but this one is from either side. So what does this do? So power 3 raises this function to the third power. Log applied to this determines the power we raise 4 to get that, and so on and so forth. What does this do to this function? Okay, it's fancy, limit of the blah blah, but what does it mean? This looks for the trend of f of x. So this one looks for power 3 applied. This one looks for log applied. This one looks for the square root applied to the function. This one applied to this function only gives us the trend of the function. Okay. So let's look at a few examples. So let's say I have this function, and then we'll look at some graphs in the book in a minute. So let's say I'm going to say this is 10. I'm going to say this is 5. I'm going to say this is function f of x. And I'm going to ask you 3 questions. I would like to write the third one here. I'm going to squeeze it in. Okay, so we haven't seen this before. Just a sip, a quick sip. We haven't seen this before. This is telling us, find the trend. Where is the function going? Function values, of course. Where are the function values, or what they are approaching? Where are they going of f of x, so the function values, when x approaches 10 from plus, with larger numbers, from plus 10, from the right-hand side of 10. Obviously, this means from the left-hand side of 10. And obviously, this one means at the same time from the left and the right. So let's look at the graph that we came up with. What is the limit of this function? The trend of the function values when x approaches 10 from the right. Before you say anything, this represents the x values, and this represents the y values. So as x approaches 10 from the right, the function values get closer and closer, closer and closer to
5.
Excellent. From the other side, as x gets closer and closer to 10, from the left-hand side, with values smaller than 10, the function values get closer and closer, closer and closer to anyone? We cannot hear you, Matthew.
Sorry, close to 5.
Good. Now, one more time. I will not be able to do this because I don't have enough hands, but maybe I can. As x approaches 10 from either side, the function values get closer and closer to 5.